In this video, we'll talk about linear functions. A linear function is any function which has a graph that is a line. In fact, you can see it in the name, linear. You see line right in there. And that's really what it means. A linear function is any function whose graph is a line. There are many ways to write a line. There are two common ones that we often employ. One is called slope-intercept form, and the other one is called point-slope form. Slope-intercept form is the familiar equation y equals mx plus b, where m is the slope of the line. The slope of the line is given by the change in y over the change in x. B is the y-intercept. So b is where the line intersects the y-axis. Now technically the y-intercept is the point with coordinates 0, b. But often, just as a shorthand or as a shortcut, we just say that b is the y-intercept, and that's okay too. But really when we're talking about the y-intercept, we're talking about this point, even if we just say that the y-intercept is b. That's because when you're talking about the y-intercept, it's understood that the x-coordinate is 0. The other form that we often use is point-slope form. Y minus y1 is equal to m times x minus x1. Here again, m is the slope. Now x1 and y1 are the coordinates of any point on the line. So we can just pick any point that we want and give it coordinates x1, y1. And point-slope form will be written as y minus y1 equals m times x minus x1. That means, since you can pick any point, that you might get a lot of different equations that look different, but actually describe the same line. And if you write them in slope-intercept form, which basically means solving for y, you'll always get the same thing. Notice that in point-slope form, if you solve for m, then you get that m is equal to y minus y1 divided by x minus x1. So for any point x1, y1 on the line, and any other pair xy, x, y, which is another point on the line, you have that m is the difference of the y's over the difference of the x's. So this point-slope form is really just a way of saying that the slope m is equal to the difference of the y's over the difference of the x's for any choice of point x, y and point x1, y1 on the line. This x1, y1, that's a fixed point. That's a fixed point on the line. But x, y, that's an arbitrary point that's anywhere on this line. So really, point-slope form is just another way of saying that the slope is the difference of the y's over the difference of the x's. The slope of the line tells you if the linear function is increasing or decreasing. If the slope of the line is positive, like you see here, that means that the linear function is increasing. As x goes from left to right, the y values get larger. The y values get larger, moving upwards. So what that means is that your function is increasing. Now, on the other hand, if your slope is negative, that means the linear function is decreasing. So as x goes from left to right, the y values get smaller, so the function is decreasing. If the slope is 0, then the function is neither increasing nor decreasing, it's just remaining constant. And in fact, the equation of this line is y equals b, where b is the y-intercept. For this example, let's determine whether each of the following linear functions are increasing, decreasing, or neither of those two. Well, you just need to figure out what the slope is. The slope is the m in y equals mx plus b. So let's start with this one, with a. So f at x is equal to minus 2 times x minus 2. So what we're going to do is we're going to distribute this negative 2. So negative 2 times x is negative 2x, and then negative 2 times negative 2 is plus 4. So the equation for the line is y equals minus 2x plus 4. This is in slope-intercept form. And the intercept is 4, and the slope is negative 2. Since it's negative, it's less than 0, that means it's decreasing. So this function is decreasing. Let's look at b. So again, we're going to do the same thing. We want to distribute that 3. I want to distribute that 3. So it's going to be 3 times negative 2/3 plus 3 times x. Now that 3 will cancel with that 3. So what we end up with is negative 2 plus 3x. So the equation of this line is y equals negative 2 plus 3x. This is slope-intercept form. But don't be confused by the fact that the intercept is written first. This is the same thing as y equals 3x minus 2. So now you can see that b is this negative 2. So the y-intercept is negative 2, and the slope is 3. So in this case, the function is increasing because the slope is positive. 3 is greater than 0. Well, there's not a lot to do with c. This is a constant function. In this case, m is equal to 0. The line is y equals negative 3, or if you prefer, you could say that y is equal to 0 times x minus 3. The slope is 0, so that means it's neither increasing nor decreasing. It's constant. Example 2. Plot the graph, this should just say graph. Plot the graph of the function in example 1a. So what we want to do is we want to plot the graph of this. Well, we know what the equation for the line is. It's right up here. It's y equals negative 2x plus 4. So y equals negative 2x plus 4. So that tells us that the y-intercept is b equals 4, which is right here. That's the y-intercept. And the slope is negative 2. That's the difference of the y's over the differences of the x's. One way of saying the slope is that it's the rise over the run, where rise tells you how high up you go, and the run tells you how far to the right you go. Well, this is minus 2 over 1. Negative 2 is negative 2 over 1, so the rise is negative 2. The rise is negative 2, and the run, which is how far horizontally you go, is 1. So that means my rise is negative, so I actually go down. So rise equals negative 2 means go down 2 units. And the run equals 1 means go to the right. So run equals 1 means go to the right 1 unit. So we can do that. So we start right here at the y-intercept, or at any point that you have on the line. We go to the right 1 unit and down 2 units. So let's go down 2 units first. So 1, 2, and then we move to the right 1, which is going to put us right there, right over 1. Well, that's close to being right over 1. Let's just try it like, there we go. That's the point right there. And now we just connect the dots. So that's a little off. There we go, that's a little bit better. So there's our line. This is the line y equals minus 2x plus 4. So the next example is going to ask us to graph the function in 1b. Plot the graphs, I should say, originally it said plot the graphs of all of the functions in example 1, but we split them up. So plot the graphs of the function example 1b. Now again, we already found the equation for this. This is y equals negative 3x minus 2. Not negative 3x, but positive 3x. 3 times x is 3x. So this is the equation of our line. So again, we can see that b is equal to negative 2 and m is equal to 3. So b is equal to negative 2. Now again, the slope is equal to rise over run, which is the difference of y's over the difference of the x's. So the rise tells you how high up you go. In this case, rise over run is the slope is 3, so that's going to be 3 over 1. So that tells me to rise by 3 and run by 1. So again, rise by 3, that means we go up 3 units. So 1, 2, 3. And then we want to run 1 unit. So run means how far horizontally you go. So that's going to put us right there. So that passes through the point 1, 1. And now we just connect the dots and we'll try to do a better job of it this time than I did last time. There we go, something like that. And that's the equation of our line, or that's the graph of the equation. Y equals 3x minus 2. Okay, plot the graph of the function example 1c. Well, this is the easiest one, because this is just y equals negative 3. So the y-intercept b is equal to negative 3, and the slope is equal to 0. It's not increasing or decreasing, it's staying constant. So it passes through negative 3, and it just stays constant. Like so. Well, I missed it just a little bit. Let's just move this line up. There we go. So this is the line y equals negative 3. You can still think of the slope as being rise over run. It's just now that this is 0 over 1. So the rise is 0. And the run, you could actually pick any number, but let's just pick 1. So that means you don't go up at all. The rise is 0, so you don't go up at all, but you do run 1 unit or 2 units, or however many non-zero units you want. So how do you write the equation of a line? What you need is you need a point and a slope. So to write an equation of the line in point-slope form, the first thing to do is find the slope. There might be different ways to do this, but the first thing to do is find the slope. The second thing to do is find any point on the line, and then you just simply write the equation in point-slope form as y minus the y-coordinate of the point, so this y is that y, equals m times x minus the x-coordinate. And the x-coordinate is that coordinate right there. So x1, y1 is a point on the line. So the equation is going to be y minus the y-coordinate of that point equals the slope times x minus the x-coordinate of that point. this x and that y stay as x and y. M is the slope, so that's going to be some number. x1 is the x-coordinate of a point, y1 is the y-coordinate of a point. So m will be a number, x1 will be a number, y1 will be a number, x will stay as x, and y will stay as y. So x and y stay as the letters x and y. So that's how you write the equation of a line in point-slope form. If you want to write the equation of the line in slope-intercept form, then you actually do the same thing. You follow steps 1 through 3. 1, 2, 3, and then at the end you just solve for y to get y equals mx plus b. Now if you already know what the slope and the y-intercept are, then you can just write it in this form directly. But this is really the same thing. You can still do it the same way. If you imagine that you're picking the point, so suppose the point x1 comma y1 is the y-intercept, 0 comma b. Then this equation would be y minus the y-coordinate equals m times x minus the x-coordinate. So y minus b equals mx minus m times 0 is 0. And then you just add b to both sides. And what do you get? You get y equals mx plus b. So really it's the same thing, as you can see. So let's do an example. So write an equation for the line passing through the 2 points given here. The first point is the point with coordinates 1, 2, and the second is the point with coordinates 4, 6. So we want to find the equation of the line passing through these points. Now, notice I say an equation. There are many different equations for the line, but there's really only one if it's written in slope-intercept form. Okay, so let's go ahead and do this. So the first thing that we need is we need the slope. So step 1 is find the slope. And how do we do that? Well, m is the difference of the y's over the difference of the x's. So y2 minus y1 over x2 minus x1. So we start with the difference of the y values. Well, here are the y values, 6 and 2. So it's going to be 6 minus 2. And then we have the x values. Then we have the x values, 1 and 4. So this is going to be 4 minus 1. All right, so one thing to keep in mind is it doesn't matter which order these points are in, but you have to be consistent. So my y's were 6 minus 2, so 6 minus 2. Since I started with the y-coordinate in the second point, I have to start with the x-coordinate in the second point as well. So 4 minus 1. 6 minus 2, 4 minus 1. Since I started with the 6 in my difference of the y's, I have to start with the corresponding x, which is 4, in my difference of the x's. Okay, so 6 minus 2 is 4, and 4 minus 1 is 3. So that's my slope. So step 2 is to find any point on the line. Find any point on the line. So we have the slope, we need a point. Well, we have 2 points. We have 2 points. You can use either one. 1, 2. 1, 2. Step 3 is to write the equation in point-slope form. So equation in point-slope form. So that's y minus y1 equals m times x minus x1. All right, well, y minus y1 is that 2 right there, equals m times x minus the x-coordinate, which is 1. So this is the equation in point-slope form. But what we actually want to do is we want to solve for y. and that's going to give us the slope-intercept form. So y minus 2 equals, oh, I forgot to plug in the m value there. Well, what was m? M was 4/3, so let's just write it right here. 4/3 times x minus 1. So y minus 2 equals 4/3 x minus 4/3. And now you just add 2 to both sides. So y equals 4/3 x minus 4/3, and then we add 2. So what we have to do now is we have to simplify this. We have to add these two together. And the way to do that is to give them a common denominator. Let's just do it over to the side. So I want to combine negative 4/3 and 2. So negative 4/3 plus 2. I have to give them a common denominator. So that's negative 4/3 plus 2 times 3/3. I want to put a 3 in the denominator, so I have to put one in the numerator as well. So this is minus 4/3 plus 2 times 3 is 6/3. And that's going to give us 6 minus 4 is 2, so 2/3. So that means that this number right here is 2/3. So our answer then is y equals 4/3 x plus 2/3. If we had chosen the other number, 4, 6, we should get the same thing, and we can just double check that. So now let's use this number, 4, 6. So in point slope form, we're going to get y minus the y coordinate equals m, which is 4/3, times x minus the x coordinate. Now on the face of it, this equation might look different. So we have y minus 2 equals 4/3 times x minus 1. And here we have y minus 6 equals 4/3 times x minus 4. So you might think that this is a different equation, but it's actually the same, and we can see that by solving for y. If we take this equation and write it in slope-intercept form, then we should end up with the same thing. So let's just go ahead and see if that works. So y minus 6 equals 4/3 x minus, and then 4 times 4 is 16/3. So now we have to add 6 to both sides. So we have y equals 4/3 x minus 16/3, and then we just add this 6. And once again, we need to get a 3 in the denominator, so you have to have a 3 in the numerator. 6 times 3 is 18, so this is y equals 4/3 x minus 16/3 plus 18/3. And 18 minus 16 is 2. So this is y equals 4/3 x plus 2/3. And as you can see, this is the same equation. So it doesn't matter which point you start with, you still end up with the same line. So let's do another example. Write an equation for the line with x-intercept 3 and y-intercept -1 in slope-intercept form. So if we were to sketch the graph of this line, so let's just draw some xy axes here. We would have the x-intercept is 3, so 1, 2, 3. So that means it passes through the point 3, 0, and the y-intercept is -1. So that means it passes through the point 0, -1. So that means the line is this line right here. Might as well just extend it the other way as well, like so. So we want to find the equation for this line. So how is this going to work? Well, the first thing to do is find the slope. So step 1, find the slope. M equals the difference of the y's over the difference of the x's. Well, we have 2 points here. Our first point is the x-intercept, which is 3, 0. And our second point is the y-intercept, which is 0, -1. So we have 2 points. 2 points. And those 2 points are 3, 0 and 0, -1. 2 points determine a line because they give you the slope. So m is the difference of the y values. So again, let's start over here. So it's going to be -1 minus 0 divided by, and now we have the difference of the x's, but we start with the x value which corresponds to the y value we started with. The y value we started with was -1. That was here. So now we're going to start with the corresponding x value, which is 0. So it's going to be 0 minus 3. So that 0 is the same as this 0. And this -1 is the same as that -1. Okay, now if we simplify this, we have -1 minus 0 is -1. 0 minus 3 is -3. So those are both negative, so the negatives cancel, and we have that the slope is 1/3. The second thing we need is a point. We can pick any point that we want. Might as well just pick the y-intercept there. So the point that we're going to use is 0, -1. So now we write it in point-slope form. So it's going to be y minus the y-coordinate equals m, and the slope is 1/3, times x minus the x-coordinate, which is 0. And now we just simplify. Y minus a minus is plus 1 equals 1/3 x minus 1/3 times 0, but 0 times 1/3 is 0. And now we just subtract the -1. And now we have y equals 1/3 x minus 1, and that's our answer. Notice that we have the slope 1/3 and the y-intercept is -1, which we knew. Y-intercept was -1. Again, if you did this with the other point, you'd get the same answer. So if instead we use the point 3, 0, then we would have y minus the y-coordinate, 0, equals the slope times x minus the x-coordinate. So this is y minus 0 is y, and then we have 1/3 x minus 1/3 times 3, which is 1. And there you have it. See, it's the same. One more example. Write a formula for the linear function with f at -2 equals 4 and f of 1 equals 5. So this is a linear function. So we can write down the formula based on this information only because we know it's a linear function. If we knew that it was some other kind of function, this might not be enough information. But since it's linear, 2 points determine a line. So we have 2 points right here. Now the points in question, the points in question are given by the function values. So when the x value is -2, the y value is 4. And when the x value is 1, the y value is 5. Okay, so now we proceed in exactly the way that we have been. So the first step, find the slope. So m equals the difference of the y's over the difference of the x's. So let's, again, like we have been, let's start with the right point, 1 comma t. By that I mean the point that's written on the right, 1 comma 5. 1 comma 5. So the y value is 5 minus the y value here, which is 4, divided by the x value that's written on the right, which is 1, minus, and now the x value that's written on the left, which is -1. So 1 minus -2, rather. Okay. So 5 minus 4, and then 1 minus a negative 2. 1 minus a negative 2. So again, that 5, well, it's a little hard to read that way. So this 5 is that 5, and that 1 is that 1. Okay, so 5 minus 4 is 1. And on the bottom here, we have 1 minus a negative 2, which is the same as 1 plus 2. And so 1 plus 2 is 3, so it's 1/3. So the slope is 1/3. 2 is we use any point. So the most convenient point here is probably 1 comma 5. So let's use that. 1 comma 5. Okay, so now we want to write the equation of the line in point-slope form. Okay, so that's y minus the y-coordinate, which is 5, equals the slope times x minus the x-coordinate, like so. Now this is the equation of the line in point-slope form. We're actually not trying to find the equation for the line, we're trying to find a formula for the function. So what we want f at x equals blah 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 blah, whatever. Now y is equal to f at x. So if we solve for y, then f at x is equal to whatever's on the right. On the right side. So let's do that. So we have this equation for a line, and basically we're just going to solve for y. That's the same thing we do when we're putting it in slope-intercept form. Let's just scroll back. Here we had the equation of the line in point-slope form, and then you just solve for y to get slope-intercept form. Here, again, we have point-slope form, and you just solve for y to get slope-intercept form. We're going to do the same thing with this example. So we're just going to solve for y. So we have that y minus 5 equals 1/3, I'm just rewriting it, x minus 1. So y minus 5, multiply the 1/3 through, so it's going to be 1/3 x minus 1/3 times 1. And now we just add 5 to both sides. Y equals 1/3 x minus 1/3 plus 5. Now again, we need to give these a common denominator to combine them. So we multiply this one by 3 over 3. So that tells us that y is equal to 1/3 x minus 1/3 plus 15 over 3. So that's 1/3 plus, 1/3 x rather. Don't want to forget your x, so it's 1/3 x minus 1 plus 15 is plus 14 over 3. And that quantity right there is your f of x, is this thing. So that means our answer is f at x equals 1/3 x plus 14 over 3. And that's our answer right there. It wanted a formula for the linear function. And there it is. Let's give a definition. Now this is something that we use in daily life. We talk about parallel lines, but let's make it a little bit more precise mathematically. So two lines are said to be parallel if they have the same slope. So if you have a first line, y equals m1x plus b1, and you have a second line, y equals m2x plus b2, then these two are parallel if m1 is equal to m2. Now what do we know about parallel lines? Well, parallel lines are lines that never meet. They never intersect. Now it's also possible that your lines are vertical. So if two lines are vertical, they are parallel, but in that case their slopes are undefined. So if you have two vertical lines, then their slopes are undefined, so this expression doesn't make sense. So this definition only applies for lines that are not vertical. So two lines, so two non-vertical lines are parallel if they have the same slope. If two lines are vertical, then we just simply say that they're parallel because they're both vertical. What about perpendicular? Two lines y equals m1x plus b1 and y equals m2x plus b2 are perpendicular if the product of their slopes is -1. So m1 times m2 is equal to -1. Now, perhaps a more natural way of defining perpendicular lines is to say that two lines are perpendicular if they intersect at right angles. But if two lines intersect at right angles, then their slopes have this property, m1 times m2 equals -1. Another way of writing that, if you solve for m2, m2 is equal to the opposite of 1 over m1. So in other words, the slope of m2 is the opposite of the reciprocal of the slope of the first line. So the slope of the second line is the opposite of the reciprocal of the slope of the first line. Now again, this only makes sense as long as neither of these lines are vertical. A vertical line is perpendicular to a horizontal line. The slope of a horizontal line is 0, but the slope of a vertical line is undefined. So in this context, the relationship m1 times m2 equals -1 doesn't make sense. So we only use it when the lines are neither horizontal nor vertical. So two lines which are neither horizontal nor vertical are perpendicular if they satisfy this relationship. So two lines, two not horizontal, not vertical. For this example, we're given two lines. 2x minus 5y equals 2, that's our first line, and 5x plus 2y equals 1 is our second line. So are the following two lines parallel, perpendicular, or neither? Well, really, we just need to figure out what their slopes are. So let's call this one line 1, and we'll call this one line 2. So we'll start with line 1. We just want to find the slope. So to find the slope, let's write this down. To find slope, solve for y. If you solve it for y, you put it in slope-intercept form, so it's easy to read off the slope. So we start with 2x minus 5y equals 2, and we're going to solve for y. So we're going to subtract 2x from both sides. So then we're going to have minus 5y is equal to minus 2x plus 2, like so. And now we just divide both sides by minus 5. So on the left, we're going to have y is equal to minus 2x over -5 plus 2 over -5. So here we have a negative in the numerator and the denominator, so the negatives cancel. So we have 2/5 x minus 2/5. So this is the equation of the line in slope-intercept form, and the slope is just the thing in front of the x. So this is our slope. So m1 is equal to 2/5. m1 is the slope for line 1. So now let's look at line 2. We're going to do the same thing. 5x plus 2y equals 1. So first we subtract 5x from both sides. So we'll have 2y equals 1 minus 5x. Now we divide by 2. Y equals 1/2 minus 5/2 x. Now I've written this in not exactly the way we normally do. Normally we put the x term first, so this would be y equals minus 5/2 x plus 1/2. And now the slope that we're interested in is right here. Once you solve it for y, you have it in slope-intercept form, so you can simply read off the slope by looking at the coefficient of x. Whatever number you're multiplying by x, that's your m, that's your slope. So in this case, it's the slope for line 2, so it's m2. So m1 is 2/5, and m2 is -5/2. Well, they're not the same, so they're not parallel. However, if you multiply them together, m1 times m2 equals 2/5 times -5/2, and that is equal to -1. So that means these two lines are perpendicular. What about this one? Are these two lines parallel, perpendicular, or neither? Well, we're going to do it the same way. So again, this will be line 1. This one will be line 2. So we just need to figure out what the slopes are. So for line 1, 8x plus 2y equals 10. So we start by subtracting 8x from both sides. So we'll have 2y equals minus 8x plus 10. And now we divide everything by 2. So divide that by 2, divide that by 2, divide that by 2. So we'll have y is equal to -8 over 2 is -4x plus 5. So the slope of this line is -4. Again, it's just the coefficient of the x term. And now line 2, 12x plus 3y equals -11. So we subtract 12x from both sides. That gives us 3y equals -12x minus 11. Now we divide by 3. So we have y is equal to -12 over 3 is -4x minus 11 over 3. And our slope is the coefficient of the x term. So m2 is equal to -4. So m1 is equal to m2. So these two lines are parallel. Notice in these computations, the only thing we were really interested in was the slope. We didn't do anything with the y-intercept. In this problem, or in this problem, we did nothing with the y-intercept. If this y-intercept was the same as this y-intercept, then they would actually be the same line. But they're not. So they're not the same line, but they have the same slope, so they're parallel. Let's do another equation where we find an equation of a line. So example 10, find an equation of a line parallel to this line and passing through that point. Now it doesn't specify if it wants it in point-slope form or slope-intercept form, but let's just put it into slope-intercept form for fun. So the first one, or rather the first step, is to find the slope. Now, how do we find the slope? Well, what we know is the line that we're looking for is parallel to this given line. Since it's parallel, that means it has the same slope. Well, there's your slope right there. It's the coefficient of the x term. So the slope is m equals -2. Because we're finding an equation for a line parallel to this line. So this line has slope -2, so our new line, which is parallel to it, will have the same slope, which is -2. We also have a point that it's passing through, 1, 4. So that gives us 2, point. Our point is 1, 4. So now we can write the equation of the line in point-slope form. So y minus the y-coordinate is equal to the slope times x minus the x-coordinate. Now really we could leave our answer here. It just says find an equation. Find an equation, and we've done that. So this would be an acceptable answer. But for fun, okay, so let me just write, this is the answer. Or this is an answer. But for fun, let's write it in slope-intercept form. Now for that, really all you have to do is solve for y. So we have y minus 4 is equal to, let's just multiply this out. Negative 2 times x is a negative 2x. Negative 2 times negative 1 is plus 2. Now we just add 4 to both sides. We don't even have to worry about fractions in this case. So y is equal to negative 2x plus 6. And that's the equation of our line. That's an equation. Now these two equations might look different, but they still give you the same line. Let's do another one. Find an equation of the line perpendicular to y equals negative 2x plus 1 and passing through 1, 4. Now this is actually the same line that we were looking at before. So y equals negative 2x plus 1. That's the same as here. Y equals negative 2x plus 1. So these are actually the same line, and it's passing through the same point, 1, 4. 1, 4. The only difference is here we were looking for a line parallel, and now we're looking for a line perpendicular. So the first step is to find the slope. Well, the slope is going to be the opposite of the reciprocal of this slope. So if this is m1 equals minus 2, then our new slope is going to be minus 1 over m1 is minus 1 over negative 2, which is 1/2. So we have m1 equals negative 2 and m2 equals 1/2. So if I multiply these together, that's minus 2 times 1/2 equals negative 1. So that means that I have found the slope to an equation which is perpendicular to the given equation. So that gives me the slope. So that's my slope right there. Now, for step 2, we need a point. Well, we have a point. It's right there. It's 1, 4. So now we write down the equation of the line in point-slope form. Y minus the y-coordinate is equal to the slope times x minus the x-coordinate. Okay, and this is actually a sufficient answer. So this is an answer. An answer. But again, for fun, let's write this in slope-intercept form. And again, all we have to do is solve for y. So our equation is y minus 4 equals 1/2 x minus 1/2. So I just multiplied all that out. We add 4 to both sides. Y equals 1/2 x minus 1/2 plus 4. Now in order to combine these fractions, I need to give them a common denominator. Well, maybe we don't think of 4 as a fraction, but it's 4 over 1, so that's still a fraction. But we want to have it with the same denominator, so we multiply by 2 over 2. So that's going to give us y is equal to 1/2 x minus 1/2 plus 4 times 2 is 8 over 2. So 8 over 2 is 4. That's what we started with. So 4 is the same as 8 over 2. And now we just add these two together, and so we'll have y is equal to 1/2 x plus 7 over 2. 8/2 minus 1/2 is 7/2. And that's our answer. Let's do one more. Find the point where the lines y equals 2x plus 2 and y equals 1 minus 5x intersect. So if you want to find the point of intersection of two lines, you're trying to find the place where they have the same point x comma y. So wherever they intersect, they have the same x coordinate and they have the same y coordinate. Well, the y coordinates are given by these formulas here. So we're trying to find the place where this y value is the same as that y value. So we want 2x plus 2 to be the same as y minus 5x. This is the y value for one line, and this is the y value for the other line. But if these two intersect, the point where they intersect, they must have the same y coordinate. So this y value must be the same as that y value. So now we just solve for x. Solve for x. All right, so let's add 5x to both sides. So that's going to give us 7x plus 2 equals 1. And of course, this minus 5x is going to cancel with that plus 5x. Now we're just going to subtract 2 from both sides. So 7x, and again, these are going to cancel. So 1 minus 2 is minus 1. So that means that x is equal to minus 1/7. So in order for these two y values to be the same, the only way that can happen is if x is equal to negative 1/7. So that means that's the x coordinate. And now we just need to use this x to figure out y. So plug into, so to speak, plug into y, plug into the equation to get y. Now when I say the equation, which equation do I mean? Well, I mean either one of these. The whole premise here is that this y value is the same as that y value when x is negative 1/7. So it doesn't matter which equation I pick, it should give me the same thing. So if I pick the left equation, y equals 2x plus 2, if I plug in this x into there, well, let's just figure out what it is. So that's y equals 2 times a negative 1/7 plus 2. So what's that going to be? That's y equals negative 2 over 7 plus 2. Now we need to give these a common denominator. So y is equal to minus 2 over 7 plus 2, 7 over 7. So y is equal to negative 2 over 7 plus 7 times 2 is 14 over 7. 14 minus 2 is 12. So that tells me that y is equal to 12 over 7. Now if I use the right equation, that is the equation on the right side, I should get the same thing. So that equation is y is equal to 1 minus 5x. Well, here's x, so we're just going to plug that right into there. So y equals 1 minus 5 times negative 1 over 7. So y is equal to 1 plus 5 over 7. Again, I need to give these a common denominator. So 1 is the same as 7 over 7 plus 5 over 7. So y, 7, 8, 9, 10, 11, 12, 12 over 7. So you see it doesn't matter which equation you use. So we have the x is minus 1/7 and y is 12 over 7. So the point of intersection is the point that has x coordinate minus 1 over 7 right here, minus 1 over 7, and y is 12 over 7. And there you go, that's our point of intersection.